Hello students, in today's lecture I will discuss about the second algorithm that is called as Bresenham's line algorithm. Before this lecture I have already discussed about the DD algorithm and which is the first algorithm which is used to draw a line on rest scan system, and we have already seen there was some limitation of DD algorithm. Because of that we are using this second algorithm, and it is called as Bresenham's line drawing algorithm. The Bresenham's algorithm is another incremental scan conversion algorithm. The big advantage of this algorithm is that it uses only integer calculations, and basically this algorithm was designed by Bresenham's. So you can see the figure, and he is Jack Bresenham, who worked for 27 years at IBM before entering academia. Bresenham developed his famous algorithms at IBM in the early 1960s. So the major advantage of using this Bresenham's algorithm is that in this algorithm we are having only integer calculations, while in case of a DD algorithm we know that we are also using the floating points, and floating point calculations are the other time consuming calculations on computer system. So that was the main limitation of DD algorithm, and in this algorithm all the calculations that we are using, all those calculations are integer calculations. Now what is happening uh, in this case, we are assuming that whatever the line we are drawing through DDA, through Bresenham's algorithm, the line is having the slope less than 1, and this is our assumption. So the algorithm that we are discussing is a Bresenham's algorithm, and we are assuming that the line which we are plotting by using this algorithm is having the slope less than 1. And we know that as per DD algorithm, whenever you are drawing any line which is having slope less than 1, in that case we are simply incrementing the value of x and we are approximating the value of y. Now move across the x-axis in unit intervals. At each step choose between two different y coordinates. So from the figure you can see that we are having one point, that is xk comma yk, and this point is having the coordinates 2 comma 3. So what we are doing, we have to approximate the next value, and we know that this line is having slope less than 1. We are simply incrementing the value of x. So the next value of x is xk plus 1. Initial value of x is xk, and we are simply incrementing the value of x, and now the value of x becomes xk plus 1. Now what about the y value? And in this we are having two options. Either I should activate yk or I should activate yk plus 1. So I have two pixels in this case. First pixel is xk plus 1 comma yk, and second pixel is xk plus 1 comma yk plus 1. So what is happening in this algorithm, we are approximating these two pixels, and we have to choose any one pixel from these two options, and we will choose a pixel which is nearer to the true path line. And from this diagram we can see that the pixel at xk plus 1 comma yk plus 1 is much more nearer in comparison to xk plus 1 comma yk. For example, from position 2 comma 3 we have to choose between 3 comma 3 and 3 comma 4. We would like the point that is closer to the original line, and in this case we know that the point which is at x is equals to 3 and y is equals to 4, this point is much more nearer to the line, and obviously we will activate this pixel. So how to choose the pixel? So what is happening? Initially we have plotted xk comma yk, and the next incremented value is xk plus 1, and we don't know that we should activate the pixel at yk or the pixel at yk plus 1. So what is happening? We are taking the distance. We are taking two distances. First distance is d1 and second distance is d2, and whatever the distance will be less, we will activate those pixels. If distance d1 is less than d2, we will activate xk plus 1 comma yk, and if the distance d2 is less, then we will activate xk plus 1 comma yk plus 1. At sample position xk plus 1, the vertical separations from the mathematical line are labeled as d1 and d2. This we can already see from the figure. The y coordinate on the mathematical line at xk plus 1 is given as y is equals to m xk plus 1 plus b. So what is happening? We are calculating this y value, and we know that this y value lies on the true path line. Okay, and we have to approximate at the position xk plus 1. So what we are doing, we are simply substituting the value of x as xk plus 1 in the equation of line. Now we are calculating the two parameters, that is d1 and d2, and we know that the distance d1 is what? It is between y and yk. So you can see from the figure, the distance d1 is what? It is the distance between y and yk. So what we are doing, we are taking the difference of y and yk, and we know that the distance d2 is between yk plus 1 and y. So again, from the previous formula, we are substituting the value of y as m xk plus 1, and here also as xk plus 1. So on this basis we can simply calculate the value of d1 and the value of d2. We can use these to make a simple decision about which pixel is closer to the mathematical line. And as I have already said that if d1 is less than d2, so obviously the pixel at d1 position, the pixel at the position xk plus 1 comma yk is much closer in comparison to d2. So next what we are doing, we are subtracting these two values. This simple decision is based on the difference between the two pixel positions. So what we are doing, we have already calculated the value of d1 and d2. Now what we are doing, we are subtracting these two values. Now as we know that we are doing the calculation for the line which is having the slope less than 1. That means here the line is having the slope less than 1, and we know that any line which is having the slope less than 1, we are simply incrementing the value of x. So here we are taking one decision parameter which is called as pixel parameter, and the value of pixel parameter is defined as delta x d1 minus d2. So substituting the value of d1 minus d2 from the above equation, we will get delta x d1 minus d2 is equals to 2 delta y comma xk minus 2 delta x yk plus c, where c is the constant. So here we are defining one parameter that is called as pixel parameter or decision parameter. A decision parameter pk for the kth step along the line is given by pk is equals to delta x d1 minus d2, and we have already seen that the value of delta x d1 minus d2 is 2 delta y xk minus 2 delta x yk plus c. Now what is happening, we are checking the sign of pk. The sign of the decision parameter pk is same as that of d1 minus d2. Okay, so here we are taking some decision. If the value of pk is negative, then we choose the lower pixel. Lower pixel means the pixel which is at xk plus 1 comma yk. Otherwise we will choose the upper pixel, and we know that the position of upper pixel is xk plus 1 comma yk plus 1. Remember, coordinate changes occur along the x-axis in unit step, so we can do everything with integer calculations. At step k plus 1, the decision parameter is given as, subtracting pk from this, we get pk plus 1 is equals to 2 delta y into xk plus 1 minus 2x 2 delta x yk plus 1 plus c. So as you know that we have already calculated the initial pixel parameter, that is pk, the pixel parameter which is at k, and the value is 2 delta y xk minus 2 delta x yk. Now what we are doing, we are approximating the next pixel parameter. For that, what we are doing, we are simply substituting the value of k as k plus 1, and whenever you are substituting the value of k as k plus 1, you will get this equation. Now what you have to do, now you have to subtract these two equations. That means you have to calculate pk plus 1 minus pk, and you will get this. But we know that the slope of the line is less than 1, so the value of xk and the value of xk plus 1, so we can correlate between these two values, and we can simply say that xk plus 1 minus xk is equals to 1. We know that we are moving across the x-axis. We know that the slope of the line is less than 1, so xk plus 1 is same as that of xk plus 1. So whenever you are taking the difference of these two quantities, you will get 1, and you have to substitute this value here. So finally, as a equation, we get pk plus 1 is equals to pk plus 2 delta y minus 2 delta x yk plus 1 minus yk. Now here we are taking some decision, and the decision is that the value of yk plus 1 minus yk, this value could be either 0 or 1, and it depends on the sign of pk, and we can see this in the coming section, in which case we are taking the value as 0, and in which case we are taking the value as 1. And whenever we are using this algorithm, we have to start from the initial pixel parameter. For initial pixel parameter, you have to keep the value of k as 0. So here we have to keep the value of k is equals to 0, and whenever you are keeping the value of k is equals to 0, you will get the initial pixel parameter, and the initial pixel parameter is defined as p0 is equals to 2 delta y minus delta x. So here is the Bresenham's algorithm, and you should keep this in your mind that this algorithm is designed for the slope less than 1. If you want to implement this algorithm for the slope greater than 1, you have to change in some values. You have to change some parameters to implement uh, the line whose slope is more than 1. So you can see from this algorithm, the first step is we have to input the endpoints of the line, and we know that uh, the line is having two endpoints, and the initial point of the line is x0 comma y0, and we are assuming that this point we have already plotted. In the next step, what we are doing, we are calculating delta x, delta y, 2 delta y, 2 delta y minus 2 delta x, and we have to calculate the value of initial pixel parameter. Now, whenever you are calculating the value of initial pixel parameter, if the value is coming less than 0, in that case, you are going to activate the pixel at position xk plus 1 comma yk, and the next pixel parameter is given as pk plus 1 is equals to pk plus 2 delta y. While in the other case, you are activating the pixel xk plus 1 comma yk plus 1, and the next pixel parameter is given as pk plus 1 is equals to pk plus 2 delta y minus 2 delta x, and you have to repeat these two steps for delta x minus 1 times. And the algorithm, and basically, and we know as we have already seen, this algorithm is designed for the slope less than 1, and for the other slopes we need to adjust the algorithm slightly. So here is a numerical of DD algorithm, Bresenham's algorithm, and in this you can see that we have to plot a line whose endpoints are 9,18 and 14,22, and whenever you are calculating the slope of the line, it is always less than 1. So initially what we are doing, we are calculating the value of delta x and delta y, which is the value of delta x is 5, the value of delta y is 4, and you can easily see that the slope of the line is 4 upon 5, which is less than 1. In the first step, what we are doing, we are calculating the value of delta x and delta y. In the second step, we are calculating the value of initial pixel parameter, and you can see that the value of initial pixel parameter is coming, it is 3, and it is more than 0, and we know that whenever the value of initial pixel parameter is more than 0, in that case we have to activate xk plus 1 comma yk plus 1. That means you have to increment the value of x as well as you have to increment the value of y. But if the value is less than 0, in that case you have to increment the value of x, but you do not have to increment the value of y. So this thing you have to keep in your mind. Calculate the pixel parameter. If it is less than 0, increment the value of x, but don't change the value of y. If it is more than 0, then you have to increment the value of x as well as you have to increment the value of y. So in this case, you can see that the value of initial pixel parameter is 3, and as I have already said, you have to simply increment the value of x, because we are speaking about the line which is having the slope less than 1. and whenever the pixel parameter value is more than 0, you have to increment the value of y. So the initial value of y is 18 and the next value of y is 19. Okay, then in the next case we can see that the next value of pixel parameter is 1, so again we have to increment the value of y. In this case the pixel parameter is having negative value, so don't change the value of y. In this the value of y is pixel parameter is positive, then we have to increment the value of y. Again it is more than 0, again we have to increment the value of y. So you can see that in each and in every time what we are doing, every time we are incrementing the value of x. So why we are incrementing the value of x? Because we are discussing about the line which is having the slope less than 1. But in case of y, either we are not changing the value or we are doing the increment. In which case we are doing the increment? If the value is more than 0, if the value of pixel parameter is more than 0, then we are incrementing the value of y. If the value of pixel parameter is less than 0, then in that case we are not changing the value of y. The Bresenham's line drawing algorithm has the following advantage and fast incremental algorithm. It is fast in comparison to DD algorithm. And in this case you can see that we are dealing with only the integer calculations. Now comparing this to the DDA algorithm, DDA has the following problems. First problem was that in that algorithm was that we are doing the rounding of the values and we are doing the operations on floating point. So these two are the limitations of DDA algorithm, and these two limitations of the algorithm are overcome by Bresenham's algorithm, and this algorithm is fast as comparison to DDA algorithm. Thank you.